This is solving quadratic equations using the quadratic formula, part 1. The quadratic formula is used to find our values of x that are going to give us an output of 0 in any quadratic equation. So in order to find these values of x, I'm going to do negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. In this formula, a cannot equal 0, and the number that we get under our radical must be greater than or equal to 0. So let's use our quadratic formula to solve a quadratic equation. So here our quadratic equation is 2x squared minus 5x plus 3. In this equation, a is equal to 2, our b value is negative 5, and our c value is 3. So if I plug this into my quadratic formula, it's negative b, which is negative 5, plus or minus the square root of b squared, it's negative 5 squared, minus 4ac, so 4 times 2 times 3, all divided by 2a, 2 times 2. So the first thing we're going to do is start simplifying. So right away I see negative, negative, this is going to be 5 plus negative 5 squared is 25 minus 4 times 2 times 3 is 24, all divided by 4. So I get 5 plus or minus the square root of 25 minus 24 is 1, all over 4. Now I know when I do a square root, I can get a positive or negative answer, which is why we have our positive negative here. So x can be 5 plus or minus 1 over 4. So now let's solve for x. So we can have 5 plus 1 over 4, which gives us 6 over 4, which we can reduce to 3/2. Or we can have 5 minus 1 over 4, which gives us 4 over 4, which equals 1. So x can equal 3/2, and x can equal 1. My two solutions. So let's look at a real life problem. So the number, y, of Northern Rocky Mountain wolf breeding pairs, x years since 1990, is modeled by the function y equals 0.20x squared plus 1.8x minus 3. When were there 35 breeding pairs? Well, y stands for the number of breeding pairs, so I'm going to plug in 35 for my y value. Now, if I want to solve for my x values here, I need to get this equal to 0. So I'm going to subtract the 35 from each side, and now I'll have minus 38. So my a value here is 0.2, my b value is 1.8, and my c value is negative 38. Okay, so I'm going to plug it into my quadratic formula. So negative b plus or minus the square root of b squared minus 4 times a times c, all over 2 times a. So when I start simplifying here, I'm going to use my calculator to do 1.8 squared minus 4 times 0.2 times negative 38, and that is going to give me the square root of 33.64, all over 0.4. So I simplify a little further, and the square root of 33.64 is 5.8. So I have two possibilities for x here. Sorry, it's my plus minus. X could equal negative 1.8 plus 5.8 all over 0.4, which will give us here a grand total of x equals 10. Or I have negative 1.8 minus 5.8 over 0.4, which gives us a total of negative 19. Now, X stands for the number of years since 1990. So we're trying to figure out when there were 35 breeding pairs. So a negative number of years isn't going to make any sense. So we get 10 as our answer. So 10 years since 1990. So in the year 2000, or 10 years later, we will have the 35 breeding pairs.